Hi everyone. One of the most common questions I've gotten from IC2 end users over the last several months is whether, when, and how Illuminated Cloud would support Agentforce Vibes or Agentforce Vibes-like functionality. I'm actually going to demo that here, but before I do so, I'd like to set some context on what Agentforce Vibes is and what it isn't, and that'll help to inform the approach taken with the Illuminated Cloud specific integration. I'm hoping the stack diagram will help to communicate that. So unlike Agentforce for developers in the past, which was a custom user interface both in Illuminated Cloud and in VS Code, communicating directly with the Salesforce API, submitting end-user entered prompts decorated with additional context, and getting back from the generative AI portion whatever it is that was requested. So that could be code, or it could be an explanation of code, or whatever it is. Agentforce Vibes is actually a collection of other components working together to provide the full experience. And at the surface level, the end-user facing level, the core component is something called Cline. It's an open source agentic AI tool that has both a CLI, which is kind of obvious from the name, and extensions or plugins for various IDEs, including VS Code and the JetBrains IDEs. And because it's open source, Salesforce has created a custom fork and done some cosmetic branding, like Cody instead of the Cline guy, and also some bundling and pre-configuration of some other Salesforce-specific aspects, things like rules. Rules are used whenever you submit your prompt in order to make sure that you don't have to type in every best practice consideration to make sure that the generated code matches the rules of the ecosystem or for your individual project or whatever it happens to be. And Salesforce has bundled a set of rules with Agentforce Vibes that include best practices and guidelines and things like that for general Salesforce development, for Apex development, Lightning Web Components, mobile, things like that. Additionally, they've included some pre-configuration of MCP servers. Now, if you're not familiar with MCP, it stands for Model Context Protocol, and it's the emerging de facto standard method by which agentic AI tools integrate with third-party tools. So I think you've probably heard me say this in the past, but generative AI and LLMs are inherently non-deterministic. You can ask the same question of one 5 times and you'll get 5 different answers. Now, depending upon how detailed and specific your prompt is, they may be very close to one another, but there will be some variability. It is still non-deterministic in nature. That's fine with regard to the code that you get back, as long as it effectively matches the input, the requirements. But when you're talking about driving some external system like the Salesforce CLI, or interacting directly with your org or a database, or keeping your CD system running, things like that, non-determinism is not a good thing. And so it's important that those tools be executed in a deterministic, repeatable, consistent manner. And that's where MCP comes in. So MCP provides an interface for execution of those tools that informs the agentic AI tool things that need to happen, the user needs to be informed of, including when the user should be prompted if it's going to potentially introduce risk or make changes in an external system. And you get the opportunity to look at the parameters that are going to be passed and such, and understand whether you should approve that activity or reject that activity, and potentially provide input into what it should have done differently. Salesforce has several MCP servers. The one that's bundled by default, or I should say automatically by Agentforce Vibes, is Salesforce DX MCP Server, which allows the agentic AI tool, in this case Cline and therefore Agentforce Vibes, to drive the Salesforce CLI for things like deploying metadata and retrieving metadata and running Apex unit tests. And it also provides some contextual information like how should it orchestrate creation of Lightning Web Components. Obviously, those are composite in nature. Where do various files get placed? Where's the unit test placed relative to that? Where should it be placed relative to the source root? So that's automatically pre-bundled. Now, Salesforce has other MCP servers, generally in an earlier release state. For example, the Salesforce hosted MCP servers, and those actually allow these agentic AI tools to interact directly with the organization to do things like get metadata about your S objects in the org, or to work with various Salesforce cloud products. So those are available, but in general, it's the Salesforce DX MCP server that Agentforce Vibes automatically wires up, because these require additional configuration, the Salesforce hosted servers. And then, of course, at the core of everything are models, the things that actually process your prompts and return whatever it is you've asked them to generate. And for Agentforce Vibes, Salesforce has automatically wired in some Salesforce-specific models that are trained, inherently trained on Salesforce programming models and things like that. And there are 2 of them. They work kind of in concert with one another. The Salesforce Pro model is a high quality, but also a higher cost to serve to Salesforce model. And users are given a limited allocation of credits per org, per 24-hour basis, and whenever those are exhausted, it automatically gracefully degrades to Salesforce Core, which is a lower quality but still decent quality model, but also a much lower cost to serve model for Salesforce. And that's used until the Salesforce Pro credits are replenished in the next 24-hour period, and then it switches back to the higher quality model. And that allows you to continue to use Agentforce Vibes while mitigating some of the cost issues, cost risk to Salesforce in terms of actually managing these models. Now, of course, with each one of these, because Cline allows all types of configuration, you have the ability to register your own rules about how your company or your organization actually manages its own development. You have the ability to use other MCP servers if you have other tools in your stack that have MCP server interfaces to them. So those can also be called from the Agentic AI tool in a deterministic, repeatable, consistent manner. And of course, if you prefer to use other models, say you've got API key for Google Gemini or for OpenAI or for Grok or for Anthropic's models or something like that, you can always use those. So this is effectively what Agentforce Vibes is. It is, again, just to quickly summarize, a forked, customized version of Cline with pre-configured Salesforce-specific rules and MCP servers and models. And so this informed what I wanted to do for Illuminated Cloud. I wanted to get as close to this as possible, and most of these I'm able to just wire in and basically provide the same experience. So we'll go ahead and walk through what is available and what's not. So first and foremost is Cline. Cline, as I said, is available for both VS Code and for JetBrains IDEs. So Illuminated Cloud will help you install and configure Cline and configure it specifically for rules. So the Salesforce rules that are automatically included with Vibes are actually in an open source repo, and I've gotten permission from Salesforce to bundle and redistribute those with Illuminated Cloud, so those are automatically included. Before I actually had the opportunity to talk to Salesforce about that, I kind of implemented a set of clean room rules for general Salesforce development for Apex and for LWC that I could distribute just in case I couldn't do the Salesforce ones. It turns out they're quite complementary to one another. Where there is intersection, I've made sure that they're reconciled, so there's not conflicting guidance going to Cline and therefore to the executing model. But they also include things, one includes things that the other does not, and vice versa. So I think they work well with one another. And both sets of rules are automatically bundled with Illuminated Cloud's integration of Cline. And as far as MCP servers, similarly, Illuminated Cloud helps to install and configure the Salesforce DX MCP server, and it helps to install what's needed for Salesforce hosted MCP servers. But like I said, there's additional configuration required for that, and so that's a stubbed configuration that's disabled by default. I'll show that in the demo. And then as far as models, this is where there's a little bit of a difference. When I talk to Salesforce about using their rules and bundling their rules, I also talk to them about maybe getting access to the models. And understandably, because there is a non-trivial cost to serve to Salesforce to execute those models, they're not comfortable making those available to third-party tooling. If they only keep them available to Vibes, they can make sure that they're not being abused or overused and therefore burning through a lot of credits, both for you as the consumer and then also for them as the provider. So they weren't comfortable with that, but that's fine because, as I said earlier, Cline and other Agentic AI tools generally provide the ability to integrate with many other model providers and their various models, both commercial and free. And free is important here because everything I'm going to show in this demo is going to be based on one of the free models that Cline provides, and I think you'll see that the quality of the output is actually quite nice and provides a very nice Agentforce-like offering without any additional cost required. So that's what Illuminated Cloud's integration for an Agentforce Vibes-alike, I'll call it, functionality will look like. Hopefully that helps to explain what Agentforce Vibes is, what Illuminated Cloud's response to that is, and helps you to understand what you're going to see in this demo. Now, I've mentioned a couple times Agentic AI tools like Cline and therefore Agentforce Vibes, but there are many other Agentic AI tools and many that provide plugins for JetBrains IDEs. And in the process of researching this, I documented all of this. So in Bitbucket, in this issue, and this may also get cloned into the user guide for Illuminated Cloud, I've documented how to set up the various MCP servers, including the hosted MCP servers pointing at Salesforce's own docs, and how to get around some quirks that I've found in that and have filed with JetBrains. I'm sorry, with Salesforce. How to set up various various other agentic AI tools in JetBrains IDEs to use these Salesforce components. So JetBrains has two, AI Assistant and Junie. There's a third called Air that was announced last week, but it's very early days for that. I'm not exactly sure how that fits in here. GitHub Copilot, a lot of people use that. It's been around for a long time. It's very kind of time tested. Windsurf, Claude Code. Of course, Cline is going to be automatically integrated if you prefer, and that's what I'm going to be showing in the demo. Zencoder, if others come about, as long as they support MCP servers and optionally additional rules to augment your prompts with best practices and guidelines and things like that, they should work just fine using this exact same approach. So this is all documented. So if you prefer to use something other than Cline, which of course is going to be integrated in a more first-class manner, it's documented how to do that. If you run into any issues, I'm always happy to answer those to the best of my ability. So having said all that, I think what we'll do is go ahead and move over and show how to install and configure Cline. Okay, so let's move over here to the IDE, and we're going to open up the Illuminated Cloud application level settings and go to the Agentforce tab. And everything at the top here has already been there, Agentforce for developers, and this will continue to be there because, for example, Cline does not support inline completion, so that will still be delivered as a feature via Agentforce for developers. But at the bottom, there's a new section called Agentforce Vibes, and it allows you to install and enable and configure the Cline plugin for Salesforce-specific development. Now, was one quick aside, I want to mention that for most people, this will say install, not enable. The reason it says enable here is because this particular machine I'm on is Windows on ARM64. It's a Surface laptop, and that particular OS architecture combination is not currently supported by the Cline plugin in the JetBrains plugin marketplace. I've logged a bug with them. I've actually created a patch for it. I've provided that patch to them. I'm going to be running that patched version of Cline here. But if I were to instead hit install, and it would bring up what it will for Intel Windows on Intel, all Mac or Linux, it were to bring up the JetBrains plugin marketplace filter to Cline. You would hit install. It would install a version that didn't work on this particular architecture. So I'm going to use my patch version here for this demo. If anybody else happens to be on Windows ARM64, let me know, and I'm happy to share that patch version with you until the patch that I've given to the Cline group gets integrated into the actual one in the marketplace. But the experience is going to be the same in terms of Cline is a dynamic plugin. So when I hit enable, you'll see over here that Cline is now over here on the right sidebar. The tool window is available, and I didn't have to restart the IDE or anything. Same thing when you install it from the JetBrains plugin marketplace. So now moving down, let's get it configured for MCP servers. Now, MCP servers are implemented as node modules, so it goes out and makes sure that the correct node modules are installed. So the first one is for the Salesforce DX MCP server, and the second is to provide access to the Salesforce hosted MCP servers. So as soon as these install, we'll see that it'll also update the Cline integration, the Cline MCP servers file. All right, so it's just done that, Cline MCP settings, this is going to have configurations for both with the Salesforce DX MCP server enabled by default and the hosted MCP server disabled by default because it requires additional configuration. And if something went wrong and you needed to reinstall, you could do that right here. And if you'd also, at that point, customize the Cline MCP settings.json file, it would prompt you to merge instead of just overriding and losing your existing configuration. Okay, and now the last part that we need to do here in terms of the Salesforce-specific integrations will be the Cline rules. So I'm going to go ahead and say install, and you can see that it put 8 Cline rule files under the OS-specific area where Cline looks for those rule files. So those are there. And similar to what I said about the MCP servers config, you can always reinstall this. And if you had customized those rules, you would have an opportunity to merge that. And over time, by the way, these will probably be revved, and you'll see an update status here. And again, that will allow you to get newer versions of the rules if newer guidelines have been implemented or added, or if I add stubs for additional MCP servers or actual entries for additional MCP servers, those would be there. And again, it would allow you to merge those if necessary. But you can always get back to the original state by hitting reinstall. So that gets these components in place. Let's go ahead and close this. And we can see here the Cline tool window, and we need to log in. And so if you don't already have an account, you'll need to create an account. And importantly, to create an account, this is not one of those where you have to register a credit card, put it on file, and have it take a 1-month payment, or it'll automatically start debiting in a month. There's an absolutely free tier. So you just create your account and move on. I've already created an account, so I'm going to go ahead and log in. And it's going to bring us over to Cline's OAuth window. And so I'm going to do this, and we should be authorized. Yep. And we're going to hop back over to the IDE, and we can see that we're now in release notes and some additional information about various models and such. And we'll go ahead and close that. And now we have Cline pretty much ready to go. So if you've seen Agentforce Vibes, it really looks like this, except you've got Cody up here and a little bit of Salesforce-specific information, but all of the chroming around all of the various controls are the same because, of course, Agentforce Vibes is inherently a forked, slightly customized, and pre-configured instance of Cline. And so really, we're going to start interacting with this the same way that we would interact with Agentforce Vibes because it's the same foundation. So first, let's verify that all the configuration was correct. So we're going to open up rules, and we can see that we have a set of rules here. The first 5 that begin with A for D, Agentforce for Developers, are the ones that have been redistributed from Salesforce, and the last 3 are the Clean Room Illuminated Cloud specific rules for the various development disciplines. And these are just markdown files with natural language that you would use like in a prompt to specify how you want things to be generated, except these get submitted every time, so you don't ever have to do these each time that you do your prompt. If it's in here, it's automatically going to get taken into consideration with whatever gets generated. So here are the ones from Salesforce for Apex, and here are the ones from Illuminated Cloud. And like I said, I've already reconciled the two to make sure that there's consistent guidance being given to Cline and therefore to whichever model that Cline is using. So we have rules. We can also see that the MCP servers are configured. So now this, you may see this. By the way, I'm not planning to do any type of cleanup on this. I'm going to show you what happens, and it may happen to you. So I'm going to hit retry connection. It should start this successfully. We'll see here in a second. Sometimes when it goes out to start the executable, there, now it started fine. You do want to make sure that's the case before you start submitting prompts because you want the MCP server to be used. So this first one is the Salesforce DX MCP server, and you can see that it's enabled and it's green, so it's started. And then the Salesforce hosted server, the one that I said is stubbed, you can see it's disabled and therefore not started. If you wanted to go ahead and configure that according to what I showed in that Bitbucket documentation, you could go into MCP servers under the configure tab, and again you can see the same information here. By the way, if you want, you can see the various tools that are available in each MCP server and the information they provide or what they do. But with Salesforce hosted, if you wanted to configure it, you could open up its JSON file. You can see this one is already enabled because the good old double negative disabled false, and this one is disabled by default. Like I said, stubbed, and so you would need to say disabled false, and you would need to go and configure your external client app for OAuth and get the consumer key and plug it in here. And like I said, there are some quirks to that. Those are documented in that same Bitbucket issue. Make sure that you're taking a look at that to understand, for example, when it's going to time out and not have an actual authorization again and things like that. Okay, so that part of the configuration looks good. The last part that we showed in that stack diagram was the models. So let's go into settings and let's take a look under API configuration at the model offering. So various API providers, like I said, Google Gemini, Anthropic, OpenAI, Claude Code, all these various models are available. And if you choose one of those, you can then choose or model provider, you can choose the specific model. You can put in your API key for the model. It's going to show you what the cost proposition is for it. But as I said, I want to use a completely free model. So I'm going to go to Cline, I'm going to go under free, and we can see that there are 3. The last one, by the way, often they kind of do a try before you buy offering on a particular model, and that's what this one is. But the first 2 are perpetually free. Of the 2, I prefer the Roo Code Fast one. That's the one I'm going to use in this demo, and you can see that it is completely free. So we're going to go ahead and have it use that. I'm going to make one other configuration change for this demo, and that is I'm going to go in and change the MCP display mode to Markdown from plain text. And the reason is the Salesforce DX MCP server, when it provides its guidance for LWC component creation, orchestration, things like that, it does it using Markdown, and that obviously renders better. So I'm going to go ahead and say done, and we're over here, and we will be ready to go ahead and start working through some prompts and looking at how this actually generates code. Now, before I do that, I want to go ahead and give one more preface, and that is I'm going to use 2 different prompts to drive 2 different scenarios. Now, I could glom these together into a single prompt, and it would generate an entire application. And what that would end up doing is obviously showing a more complex use case, but it would also take a lot of time. And in the interest of your time, I want to break it down into just a couple of prompts that I think will convey the information I want to convey here. The first one is going to be around both Apex and Lightning Web Components code generation. including generation of unit tests, deploying to the actual organization, using the MCP servers, and making sure that things both deploy and pass, iterating as necessary to get to that point. And the second one is going to be around custom S object metadata, custom S objects, custom S object fields, and some considerations around that in terms of the IDE interface and making sure that things like the OST get generated, things like that. So we're going to work through both of those in turn. As we do, I'm actually going to provide color commentary, just kind of telling you what I'm seeing. Now, I'm going to talk about how the execution of this particular prompt compares to previous executions. Like I said, this is non-deterministic, so it almost certainly won't be exactly what I've seen before. How it's using the rules, or if it's not using the rules, we can I'll comment on that. How it is using the MCP servers, things that it is prompting the user for authorization in order to proceed, and things that you might auto approve and things that you wouldn't necessarily want to auto approve, at least in my experience and in my opinion, and just kind of talk through it. Now, that is obviously going to be potentially long running. Hopefully it will be closer to like 5 minutes than 10 minutes per prompt, but I don't know. Again, it's non-deterministic. So I'm going to put several bookmarks in this video to allow you to very easily move to the next section and kind of get past, frankly, my rambling. If you'd prefer to do that, you're not going to hurt my feelings by doing that. But if you want to follow along at home and just kind of see how the prompt actually proceeds and what Cline does with that and how it uses all the various tools and things like that, then I'm actually going to do that and not just fast forward through that. So hopefully that makes sense. So what we'll do in just a moment is we'll jump into the first prompt. Okay, so here's our first prompt. Like I said, it's LWC and Apex. And yes, you've probably seen this before if you've seen my other generative AI videos. So it's going to be generating the Fibonacci sequence, the recursive implementation of it in Apex. But this is where things are going to be different. Is it also needs to generate unit tests. It needs to deploy to the org. It needs to run unit tests. And if there are any issues with deployment or unit test execution, it needs to iterate until it's fixed those. And once that's done, we want to create an LWC component that allows the user to enter a number and it shows the Fibonacci value of that number. That also needs unit tests. I don't want it to create a JavaScript native implementation of Fibonacci because we just generated an Apex version of that. So I want it to remote the Apex implementation of that. Again, we want to deploy and run tests, iterating until all of that is clean. So I'm going to go ahead and launch this and we'll see where it goes. Now, one thing that happens very often, but not always, when this starts is it just takes a look at the project structure itself. That includes the directory structure. It includes files like sfdx project.json and things like that in order to understand what it needs to do. So it looks like it's looking at the source root. And let's see here. It looks like see, it's skipping those tasks. So it's just going ahead and jumping in. And we've hit our first approval prompt. So it's saying it wants to create a file. We can go over here and see that it's actually already created it. But if I say reject, it'll back that out. It wants to create a file. And of course, we've asked it to generate code. So we want it to be able to do that. And we don't want to have to answer this type of an approval prompt each time. So I'm going to go ahead and auto approve editing of project files, and not editing of all files because I want it to still be contained by the sandbox that is the project directory, but it can edit files here just fine. And so I also want to say that when it says edit, it's adding files, but if it had to edit existing files, and it has some guardrails around that as well, that's fine because this is checked into version control. So any changes that it makes, if I needed to back out, I could back out to the last good version control state. Plus, Cline is creating checkpoints along the way, and I could always back out to a previous checkpoint. Okay, so I'm going to go ahead and auto approve creation and editing of files within the project and say save, and it's going to go ahead and keep moving on. This looks like a pretty straightforward implementation, recursive implementation of Fibonacci. So far, so good. I'm assuming next it's going to create the meta XML file for this. And before it does so, it's consulting sfdx project.json, I think because of something that's in the rules, in order to get the API version number to use in the meta XML file for this and make sure that it matches kind of the baseline project API version. So let's see. Yep, the API version 65. That's what we're going to use in the meta XML file. And so next I would assume that it's going to move on to generation of tests. Yep, there it goes. And then we'll need a meta XML file for that. So far it's executing against the prompt. And something I didn't show is it's created its own checklist here for its execution strategy. And we can kind of watch it make progress through it. But this is, it's basically going to do exactly what we asked it to do. All right, and so we have our test, we have the meta XML file for the test, and now it's ready to deploy to the organization. So what it needs to do in order to do that is use the Salesforce MCP server. Again, talking about the rules say to use MCP servers before it kicks out, say, the command line, because they provide a more controlled interface to the things that they support. And so for deployment and retrieval and things like that, the tools provided by the Salesforce DX MCP server say, well, the first thing you need to do is you need to assess the username / alias for the current project so that that can be passed as an argument to those tools. So it's going to go ahead and do that. Now, this will be a good candidate to auto approve because it's a do no harm type of operation. It's not making a change to your project. It's not making a change to your org. So there's no reason to have to approve this each time. I'm not going to auto approve any of the MCP tools right now, just so that if they come up again, we can kind of talk about it. But it should come back, and it should, down here's our connection, Agentic AI test, and that matched what it found, and we can now see that it's going to deploy. This is not one I would auto approve personally. I would not auto approve anything that makes a change to a sacred environment. Now, this is a scratch org, so it's not super sacred, but I mean, I may have invested a decent amount of time in this, so I want to see that it's going to go to the right org. That's what's more important. Is this? It didn't choose production here or something like that. So it's going to deploy the Apex classes, the Fibonacci calculator and its test, to Agentic AI test in the context of the project directory. So that's fine. I approve that. I don't auto approve it, but I do approve it. And so it's going to go ahead and do that deployment. And then my guess is everything's going to deploy successfully, and it's going to move on to unit tests because this is a fairly straightforward implementation. And sure enough, deployment succeeded. Now we're going to run the test. This is another one you could auto approve. It doesn't make any real changes in the org. Yes, it may update code coverage metrics as metadata in the org and things like that, but it's not going to make any changes to the things that you manage in version control or any of the actual Salesforce data. So we'll go ahead and let this run. After verifying it's running against the correct org, and so we'll go ahead and let this run, and we'll see if the tests pass, and we'll see if it provides any coverage information. Let's see, test ran passing 2, so it looks like we're in good shape there. And now it's moving on to whatever is next. So we can go ahead and take a look at that in its checklist up here. Looks like it finished all the Apex things and is moving on to Lightning Web Components. So let's take a look. Now we're getting like Lightning Web Components. So it's created the component directory. It's created the HTML template. Obviously, it'll create the JavaScript file, actually, right as I said that. It may or may not create a CSS file. I've seen it created. I've seen it not created. Again, non-determinism with this. I've seen it created, and it's completely empty, just a stub. It obviously will need this, the meta XML file. So far, it's continued to manage the API version, which, by the way, in the rules, I said it'll get it from SFDX project.json. If that's not present, say in a metadata format project, it would check for package.xml for the reference API version. Now it's creating the jest test. So far it's kind of cruising right through this. And my guess is next it'll try to deploy, and then it'll try to run tests. Of course, it doesn't need to deploy before it runs jest tests. They execute locally, but the order of operations we gave it in the prompt was that it should deploy the LWC component before it tries to run tests. So it's going to try to deploy the LWC component to Agentic AI test from the context of the project. Again, everything looks good there. We'll see if there are any errors here. And if there are any errors, then obviously it'll have to make some changes. And there were. So this is something I see from time to time. Even though the rules say that the braced expressions have to be simple property or property subproperty references, that they can't be complex expressions, sometimes it still generates them. But the good news is it detects that quickly and will encapsulate that more complex composite expression in a property on the JavaScript side and then substitute the original expression with just the property. And it just did exactly that. So now we're going to deploy again, and hopefully this one passes. But we are getting to see it iterate on, say, deployment errors and identify the deployment error, identify the reason for the deployment error, and to fix the deployment error correctly. So it's also looked at package.json, and it's determined that in order to execute jest tests, it has a tool that you can use to do that. And so it's executed that, and it has some failures and some passing. And we've asked it to iterate until things pass. Now, we'll say this is one place where it can kind of spin a little bit. Hopefully, it'll get through these pretty quickly. I've seen it do so, and I've seen it not do so. There are some guardrails against that in the rules. For example, in the rules, it does say about execution of tests that if it gets to a point that it just cannot get them to pass after a certain number of iterations, it should just stop and report that in the final summary of what it's generated, so that you know, as its pair programmer, you know that you need to go and address those. And and it will keep it from just burning through credits if you're using a commercial model that has a cost associated with it. You don't want to walk away for lunch and come back, and while it's basically going back and forth, trying to get your Jest test to pass, it's burnt through all your credits and run up a pretty high bill. Okay, so it actually managed to get all these to pass. That's wonderful. So we should get a summary of where we are right now. Let me go ahead and scroll down to the bottom. Yep, we did. Okay, so let's look at what it says that it's done. Well, it created a Fibonacci calculator class. Let's take a look at that. We're going to talk in just a moment about these yellow things. I said earlier that we would talk about some post-processing steps in order to get this ready to check into version control. But we can see that this is yellow at worst, and it's very simple things. But obviously, it seems to have generated that. It says that it created the test. Oh, it says it added Apex doc. That's also in the rules. It added error handling. We can see that. It created the unit test. So let's go over here. So this test actually shows up as green. When I say that, I mean up here with regard to the inspector. And some things to point out. The rules say that it should use start test and stop test correctly. It should use the newer assert assertion methods, not the system.assert methods, and it seems to be doing that fine. In terms of what it's actually created, it's created ones for base cases and for small numbers, and then it's also created ones to test negative input to verify that it gets the correct exception. In terms of like passing a -1, there is no fib of -1. That throws an illegal argument exception. It gets that with the correct message. Then it says that on the LWC side, that it created the actual component. Here's the markup for it. And it looks like very well generated, well organized markup. Here is the JavaScript for it, and it's even used JSDoc to document it. And it looks pretty darn good. And again, it shows up green, which honestly, I don't see that very often. Sometimes there's always something there. And then the test itself, flip over to the tab for that, and here's the Jest test, and it probably has some small things like a duplicate code fragment, yeah, some very small things that we could certainly look at. The set timeouts here, you can, by the way, on these, you can try to have the AI tools fix these for you, both Agentforce for developers and Cline. Again, non-deterministic. Sometimes it will, take out the set timeout. Sometimes it will just go ahead and add a suppression above it because it's saying this is what I wanted to do. So we're just going to go ahead and make it so it doesn't get reported as a warning. You can try those or you can fix them yourself. But in general, it seems to have generated some quite nice code. Okay. So what do we do to take ownership of this? Well, the first thing I'm going to do is just go and run it through the formatter. So yes, when it inserts code, it uses your code style, but there are some post-processing steps for the formatter, like the Apex doc formatter and the one that makes sure that the case of keywords in Apex and of references to identifiers, since Apex is a case-insensitive language, that they match the canonical format. Those get run as a post-processing step, so they're not run on paste. So let's go ahead and do that. So that code's been reformatted, and let's go see. So for example, all the yellow's gone here. It automatically updated add exception to @throws, which is what the current Apex doc inspection says, and it updated cacheable from lowercase c to uppercase c because that's what we had specified in our code formatter for Apex. Everything else was pretty much green except for the test that those aren't things that would be fixed by the formatter. And now we could go ahead and deploy those changes, get those into the organization. So in this case, it's against the Scratch org. So I'm going to go ahead and push. And once those get deployed, then the next thing that we could do is just put these into a change list and we could get them checked in. I can even show in just a moment, in fact, I can do it right now, that we can run the tests here locally while it's deploying. See right here. We'll go ahead and run these with coverage. Let's see how our Jest tests do. All right, so all the tests pass and they provide 100% coverage. That's wonderful. So you now can obviously evolve and iterate on these locally now that they've been generated using the IDE's own native tools for Jest test execution, for Apex test execution, things like that. By the way, the push was complete in the background. Let's go to the Apex test. Same thing, we'll say run with coverage, and hopefully all tests will pass completely. They should. Said that they did. So we got green there, and again, we've got 100% coverage. So that's great. Okay, and so now let's go into version control. And I'm going to add these to the change list. And actually, I'm going to add them to this Apex and LWC change list. So we'll just kind of set those aside, but that's our Apex and LWC scenario completed. Okay, so that's the first scenario. Okay, so let's go ahead and start that second scenario. So I'm just going to click Start New Task, and here's our prompt. And it's very simple. We want to create a custom object with one custom field. I want it deployed, fixing any deployment errors. I want it to create an Apex class for creating instances. The whole reason for that is I want to see references to the custom object name and custom field name. And so there's no need for unit tests for that. It doesn't even need to be deployed. It will, even without being deployed, it'll evidence the set of issues I want to show and how to resolve them. So let's let that start executing. And as that's executing, I want to point out that the rules also say that if it sees an sfdx project.json, the project should be considered source format, and it should use metadata decomposition for generated, say, object files. And if this is absent, it should be considered metadata format. Now, to be fair, it doesn't actually always do the exact right thing, but if it generates something that deploys, you can always launder the metadata through the org. So deploy it and retrieve it, and it'll come back in the correct on-disk format before you, say, check in. Now, it seems to be starting by creating correct decomposed metadata for this. We'll see if the field gets put into its own file. It did. Okay, so it seems to be doing the right thing. Again, if it didn't, as long as it deploys, because the native format is monolithic anyway, as long as it deploys, you can always get it in the right format, either by laundering through the org or by using the Salesforce CLI to convert. So now it wants to deploy the object and the field, and so it needs to get the username. Let's verify that it's the right username. Agentic AI test, so that's great, and that's what it's deploying to. Now, it's going to fail. We can see that there are some issues here. So there are a couple of elements that are just not valid. So it's going to fail for those reasons. It's going to fail for a third reason as well that we'll see. And so it's going to have to go through several iterations here. So I'm going to approve this, and we're going to allow it to iterate on deploy, fail, fix, deploy, fail, fix until it gets to deploy successful. So it's taking out market data translation, and then it will ask to deploy again. And it's going to fail, enable change data capture. I believe that's going to fail again, and we'll see what the other issue is. Now, the issues by which it's failing here are things that could be codified in the rules as well, but because I don't know what API version people are on and exactly what they want, those are better added by you based upon your knowledge of your own project. So if you want to add those to avoid these really unnecessary iterations, that's easy to do. I might be able to add a rule that says if the API version is like this. So the third one is this. It says that there was not a name field. So because name is a special field on S-objects, it's a known, just like ID. So it had to add that as an actual name field. That should be our last failure, and it should get it deployed. Assuming that it does, it's going to generate the Apex class that gives us references to the S-object, custom S-object name and custom field name, and we'll see what happens there and what needs to be done to fix those issues. And so here we are. And we can see that there's a whole host of problems. We got 14 errors in there, I think I saw. So in just a moment, it's going to say it's done. And we'll go talk about post-processing. Yeah. So again, its summary is it created the object, it added the field, everything, string type. It was able to deploy everything. It talks about the issues that were that needed to be fixed to deploy it. It created the class that effectively is a factory class for these, and it did not try to deploy it. It did not try to add unit tests. Okay, so what are the issues that we have here? Well, first, let's do the same thing we did earlier and do some formatting, but that's not going to fix this, but it will take care of some other things. And so now let's talk about what's going on with these errors. Well, these errors are because it created a new object, so S object, it created a new field, and even though it deployed those, the offline symbol table has not been updated, and these are resolved against the stubs in the offline symbol table. So we need to update the offline symbol table. So Illuminated Cloud is going to help you do that. Just bring up the context actions using Alt-Enter or Opt-Enter, and the first entry says to generate the offline symbol table, but only the S-objects portion, which is quicker than doing the whole thing. So we're going to go ahead and do that. And once this gets done, and it gets done with the indexing required, it should be able to resolve these, and then we could move these into their own change list and go ahead and check these in if we wanted. So the second scenario is just meant to show that when you're generating all this code, using say Cline in this case, or Agentic AI, or just generative AI, it may generate some things that aren't completely reflected in the things that Illuminated Cloud uses, particularly the offline symbol table, to have consistent references and a consistent view of what your project is. And so you may need to go and do some type of simple post-processing there in order to make things whole from Illuminated Cloud's perspective. Generally generating the offline symbol table, and that may be all of it, or in this case, and you can see they resolved correctly now, and we only have a little bit of yellow about things being unused because this is a completely unused class. And we'll just go ahead and say suppress that for the entire class, and we should see this go completely green. So we're in good shape here. So there may be some post-processing needed depending upon the type of metadata that was generated. And now I could go ahead and push the project again and get the org completely up to date, and every single bit of what we've generated will be in really good shape. And I'm going to show one other thing that you might do in order to put things into really good shape. But first, we'll move this into its own change list, move to another change list, and we'll say that this is custom object and field. Okay, and so now we've got kind of change lists for each of the tasks that we did. And now let's go and actually diff our metadata against the org. And you've probably seen this before. The org may reorder elements in XML files. It may add some with the default values, whatever it happens to be. And I apologize, I have my IDE set up to use Beyond Compare as an external diff tool, but this would just show up in the IDE's internal diff tool. So Fibonacci calculator, it's just a test. Those are client side only. We can ignore tsconfig.json, but when we get here, it's got some other things. So for example, the field, it's added track trending, so we can bring that over. It's got an all list view. We can bring that over. It has a master record type. We can bring that over. And for the object, it's got some various action overrides and some track history information, record type track history, empty search layouts. So we'll go ahead and bring that over, and we can deploy again. So we've brought that over. Let's deploy again. And then after that, we'll do another retrieve, and we should see that things are fine. By the way, now what it's saying is that there are potential conflicts because this was all generated and deployed originally, not through source tracking. And so what we're going to do is say that what we have locally is canonical because we just retrieved it from the organization. We know that it is. So we're going to do a force push, and now it's pushed, and that's fine. And we'll go ahead and do another retrieve for diff. And it should show that the only differences are effectively the LWC. Let's take a look here, the LWC tests and tsconfig. So now we basically have the exact same representation of generated metadata that the org has. And we'll move these into the custom object and field because they're part of it, and we're done. So that's the second scenario. Okay, so that's what I wanted to show. Hopefully what you've seen here is that by integrating Cline with the Salesforce specific rules for best practices and guidance and guardrails and things like that, and the Salesforce MCP servers, and using the free model from Cline, you get a very effective agentic AI tool that is effectively very similar to Agentforce Vibes because it's based on the exact same underlying agentic AI tool. And if you want to use your own model, if you want to bring a key from one of the other high-end commercial models or whatever it is that you found to be the most effective and efficient, then by all means you can do that and get even better results. So this is the Agentforce Vibes alike in Illuminated Cloud, and everything that I've demoed has no additional cost associated with it. I would love to hear your feedback on this. I'd love to hear how it's working for you. I'd love to hear if you decided to use other models that provided a better experience. If you have ideas on how to improve the bundled rules, if you've made changes that are applicable to all of your projects and should actually be applicable for someone doing Salesforce development, then certainly let me know. If those get incorporated into the bundled rules, I'm happy to provide recognition and appreciation in the corresponding release notes. If you find any issues, let me know. The main issues would be with regard to Illuminated Cloud, would be with regard to the way that things are integrated here in Agentforce Vibes. If you see issues with Cline itself, those are better opened in the Cline public issue tracker because it is a completely separate product. If you have issues getting the MCP servers going, let me know. I can certainly help with the Salesforce DX MCP server with the Salesforce hosted MCP servers. I've documented all the quirks I've found, but they are still in an early state, and a lot of those are probably better consulted with Salesforce to try to get those going. Otherwise, like I said, I hope you find this useful, and I hope this is kind of what you've been looking for an AI-driven pair programmer for Salesforce development. And otherwise, thank you very much for your time, and take care. Bye.